Hello everybody, welcome to the next video in our GMAT Ninja Quant series. Now the title of this video is Counting and Sequences, which I know it might not be the most clear title. You might not understand exactly what we're talking about. So before we go any further, I'm going to put a couple of examples straight up on the screen. Now we're not going to do these examples, it's just to give you an idea of what we're going to be looking at later today. So when I talk about a counting question, as you can see here, that's the sort of question where you're asked to add up or find the sum of a series of numbers. When I talk about sequence question, it's the sort of question where there's just a string of numbers, maybe there's subscript notation in there. Maybe you're asked to do something with that sequence, find a term or find the gap between the terms. So to break down what we're going to cover, I'll take these questions away and show you up here. So the big bit of this video is pattern recognition. The difficulty level of this video is not that high if you can spot the pattern. If you can't spot the pattern, you're going to be in a lot of trouble and they might take you a fair amount of time. The early questions of this video, they're going to be pretty easy. We've got 3 on counting, specifically on counting, 2 specifically on sequences, and then we've got a section at the end that's just spot the pattern type questions. They might mention counting, they might mention sequences, there might be a bit of everything. If you can spot the pattern, you should be fine. If you can't, you're going to struggle for a while. So we'll look at what to look for in a question that will help you get through it. Now, in the counting part of this video, we'll take a look at how to find the number of terms in a list of numbers, or finding the sum of that list of numbers. In the sequences section, we'll definitely take a look at understanding subscript notation. And throughout, we'll be looking at, I know it says sequences questions there, but really we're looking at everything, converting sequences questions into algebra. We're looking for how to convert all of these questions into algebra so they're something you can solve comfortably, easily, because once you understand the pattern, once you get the question up on the board here or on your board when you're working, they're usually relatively easy to solve, and we'll look at how to go about getting them set up. So this video is for you particularly if you get intimidated by big numbers or weird notation. Some of the numbers in the counting questions get pretty big, and maybe you've never seen the subscript notation before. You just don't know what that means. We'll dig into both of those questions as we go through the questions we've got in this video, and hopefully by the end of today, you'll understand them a bit more clearly. Then, for the most part, yeah, this video is for you if you're performing a bunch of steps and you don't really know why. We get a lot of students in when we're looking at these topics that it feels like they've just eaten a textbook and they're just regurgitating these formulas back at us. If you feel like you don't intuitively know what to do, that's where we're going to spend most of the time today. Yeah, what do these questions actually mean? How are they phrased? What are they asking you to do? As I said earlier, if you can understand that, these questions normally aren't too bad. All right, so the way this will work is I'll get a question up on the screen. We'll give you a couple of minutes to work through it, and then I'll take it away and we can look at the solution together on the board. So without any further ado, I'll get the first question up on the screen for you, and I'll see you back here in a couple of minutes' time. Okay, if you've watched any of our videos by now, you know how this routine works. If you need any more time to take a look at this question, feel free to pause the video now. We'll still be here when you're done, but I'm going to take it away so that we can take a closer look together. All right, so this seemingly easy question trips quite a few people up. I'm going to shrink this right down so that you can see what's going on, and then we'll expand it back up and look at the whole question, and we'll talk about how this relates to everything else. So let's say rather than 460 meters, let's just say the farmer had 40 meters. Okay, there we go, 0 to 40. And we're still going to plant one tree every 15 meters, right? So you might say, fine, I'm going to plant one tree at 15 meters, one tree at 30 meters. The next one will be at 45. The road's finished. I'm done. I can only get 2 trees in there. And yeah, it might be fair, but how about if we just shuffle things around a little bit? I'm going to move all of these trees 3 meters to the right. So I've got one tree at 18 meters, one tree at 33 meters. Yeah, the next one's going to be at 48 and I can't get anything more in there. But if we look at the gap on the left-hand side, well, now this gap is more than 15 meters and I could squeeze another one in there at 3. So in this case, yeah, 40 meters of road, but I could get 3 trees in rather than 2. Even though 40 divided by 15 is 2 and a bit, and get that third tree in there. So if we can expand this up to 460, yeah, the nearest multiple of 15 that you might think of in this set of numbers would be 450. Yeah, 450 divided by 15 would be 30. And so your brain might immediately jump to, well, I could fit 30 trees in there. But again, let's just shift them all by 1, 2, 3 meters, and then we can plant that extra tree in right at the beginning. And so really the maximum number of trees the farmer could plant here is 31. Now, at this stage, we get into the conversation of, is this sort of a trap question, trap answer? And I say, well, GMAT is never going to set out to trap you. Everything you need is written here. It's just about how carefully you think about the situation and what you're doing. A lot of the problems that we see with these questions are if people just try to rush through them. And if they seem easy, they seem like we know exactly what we're going to do, so I'm just going to zoom through them. Whereas if you just give yourself a little bit more time, take a step back, go, what's the situation? Yeah, what's the maximum number of trees the farmer could plant here? It doesn't have to be 15 meters, 30 meters, 45 meters, 60 meters. That's an assumption you're making. It's not in the question. They're not telling you to do that. There is no trap here. But with all of these questions, again, we talked about the pattern spotting at the beginning. It's easier to spot the pattern if you give yourself a bit of time and space, slow down a bit, read the question carefully. You'll usually end up being a lot quicker through the overall quant set if you do that. All right, so yeah, this was about the number of terms you could fit into a pattern of numbers. I'm going to take that idea a little bit further with the next question. So let me get this next one up on the screen. I'll see you back here in a couple of minutes' time. Okay, now's the chance to pause it if you need a little more time to work on this one. I'm going to take this question away so that we can look at this solution together. So as we said up at the top, a lot of this video is about pattern spotting. If you were comfortable with the scenario, if you understood what Amira was doing and you could create the sum, hopefully this question wasn't too difficult. But if it was, let's go break this problem down so that you understand how it works and where it's going. So yeah, the scenario we're given is that she has $100 in her savings account, and then each week she's going to put a little bit more in. Starts with 120, and the amount that she deposits each week goes up by $2. So 120, 122, 124, 126, and that goes up and up and up until it gets to 178, 180. And after she deposits the 180, at the end of that week, I want to know the total balance in that savings account. So in order to turn this into an algebra, for now, I'm going to ignore the 100. I'm going to put that to one side. We'll add that on at the end. I'm going to look at the sum first. And really, if we break this down, strip away the fact that we're dealing with money and just look at the situation involved, then I want to do 120 plus 122 plus 124 plus 126, all the way up to 178 plus 180. To make this as formal as possible, I want to find the sum of all the even integers between 120 and 180 inclusive. Now, at this stage, you might break out one of the formulas. There are plenty of summing a sequence of numbers formulas out there. I'm not going to do that. Reason being is that the pressure of the exam tends to do funny things to people's memory. And what I've found is that if we just give somebody a formula, they'll go and memorize it. But if a question like this comes up on question 29, 30, 31 of the exam, and you've only got a minute, maybe 2 minutes left, and the time pressure is really hitting, then that tends to do funny things to people's memory. They either forget a variable or they get a couple of the variables muddled up, and they tend to get these questions wrong, even though they're not that hard and they possibly shouldn't. So we're going to look at a different way to sum up a series of numbers. Now, if I looked at this and just asked you to find the average, again, being a bit hand wavy, asked you to find the mean, what would you do? Well, most likely you say, well, I'm just going to add up that list of numbers. I'm going to find the sum of all the numbers from 120 to 180 and divide it by n. Well, in this case, we don't want to find the average. We actually want to find the sum. So I could rearrange this equation to say, well, the sum is just going to be the average times by the number of numbers. Now, at first glance, you might say, well, that's just made things more complicated. You haven't actually helped. But there's a bit of a shortcut we can take here. Because the GMAT is only really going to ask you to sum up a sequence of numbers if it is symmetrical and evenly spaced, we can find the average fairly quickly. In a set like this, 120 to 180, they're all even numbers. The gap between each number is always 2. Then the mean of that set, the average of the set, is going to be the same as the median. Or if you want a fairly quick way of finding it, we just take the smallest number, add it to the largest number, and divide that by 2. So 300 divided by 2 will give us 150. So the average here is going to be 150. Now we need to find the number of numbers because we're going to multiply 150 by that. Now in this case, again, various ways of doing it, but the way I'd suggest you do this is I'm going to take the biggest number, take away the smallest number. So I found the range of that set. Now I take that range, and because I'm only looking for the even numbers, I don't care about 179, 177, 150. I don't care about any of the odd numbers. There would be, or we would expect there to be, 30 even numbers. It feels like it should be 30. 120 to 180, it feels like it should be 30. But because my set starts and ends with an even number, then it's not 30. I actually need to add 1 at this stage. There are going to be 31 even numbers. And again, if you're skeptical of this, the set's small enough, feel free to pause the video here and actually write them all out and check that. There are going to be 31 even numbers between 120 and 180 if you include the 120 and the 180 at the end. Now, yeah, this is the way that I would follow. Now this, divide by 2 at that stage, that only applies because we're looking for the even numbers. If this was find the sum of all the multiples of 5 from 120 to 180, that would be a 5 instead. If it was all the multiples of 3, it would be a 3. If it was all the multiples of 10, it would be a 10. That number changes depending on what you're trying to sum. As I say, if it was like the multiples of 7, it would be a 7. In this case, we're dealing with even numbers, so it's going to be 2. Now, this plus 1 at the end only happens when the start and the end of the set are the thing we're looking for. In this case, we're looking for even numbers. 120 is an even number, 180 is an even number. If you were asked to add a set that wasn't like that, for instance, if we took that one and just stretched out, if I was asked to find the sum of all the even numbers from 119 to 180 inclusive, Well, all I would do there is say, okay, I'm looking for the sum of the even numbers. 119 is not an even number. I'm just going to shift this question and say, well, now I'm looking for the sum of the even numbers from 120 to 180, and I can follow this process. Again, that +1, it doesn't feel right, but play around with it for a while. It does work. There are 31 even numbers in that list. Okay, now that we've got the two bits we need, the average and the number of numbers, all I need to do is say, well, the sum is 150 times 31. Now, as I've said in a few times in some of these videos in the past, please don't feel like you have to get to the answer in one step at this stage. 150 times 31 is not a nice multiplication at all. That's fairly tough. But what I could do is break that up, 30 plus 1. And now this becomes 150 times 30 plus 150 times 1. Well, 150 times 30, that's 4,500. 150 times 1 is just 150. So that's 4,650. Now we're nearly done, but we're not there. So please don't jump and go for B. Remember right at the start, we said that we were going to ignore that $100 and leave it right till the end. Well, now that we've added up all the 120, 122, 124, all that, now we need to add that back on. So our final value will have that 4,650 plus the 100 that Amira started with. So 4,750 is going to be our final answer. And the answer to this question is going to be C. So if up till now you've been doing counting questions using the great big formula, again, if it works for you, I'm not going to stand here and say that you have to change it. But what I've found is that this way, once you understand it, once you know where it's going, it can be more reliable because there's a little less intricacy to remember. Again, that time pressure right at the end does funny things to people's memory. Play around with it. Maybe you need to watch this question a couple of times just to understand where I was going with that bit about the need to add one at the end when you're finding the number of items in a set. But this can be a more reliable way to add up sets of numbers. All right, I will get this question out of the way and we'll put the next one up. I'll see you back here in a couple of minutes' time. Okay, if you need a little more time on this one, now's your chance to pause it. But I'm going to take it away so that we can work through this one together. Now, questions like this, the students I work with tend to find questions like this very frustrating. They look easy, they feel easy, even as they're being set up, they seem easy. But if you don't set this up right, they can get very fiddly. And there's just so many chances to make one of those really frustrating errors that say, what was I doing? So what I'm going to do here is I'll show you three different ways to look at this question. The first two are maybe the way that you thought of, maybe the typical first reaction here. And the third way is maybe the most efficient way that hopefully that you'll take away from this video. Now, what I normally see students do is they go, okay, nine books, starting from some unknown price. The next one's going to be $1 more expensive. The next one's going to be $1 more expensive. And then at the end, they're all going to add up to $49.50. And they begin writing out some great big equation. They make the first book X. Don't know what it is. I'll just call it X. The next book, the price would be X plus 1. The next book, the price would be X plus 2. The next book, the price would be X plus 3, and so on up to X plus 8, and the whole thing costs $49.50. Again, there is nothing wrong with that method at all. It will work. It will get you there. You just got to be careful. It's so fiddly. There's so many variables in that great big long line. There's a huge chance of making a mistake. The second way I've seen people do this is very similar. In this case, the unknown, the X value, was the cheapest book. But we're not really looking for the price of the cheapest book. So there's going to be a couple of extra steps at the end there once I found X. The other way I've seen people do this question is say, well, I'm going to make the fourth cheapest book my X value. So they'd go 1, 2, 3, fourth cheapest book, that would be X. And then the next one would be X plus 1, but the one down would be X minus 1, and X minus 2, and X minus 3 down to, so the cheapest book would be X minus 3. And again, you'd work your way up, and the whole thing would be $49.50. Again, very similar to the last one. It's a couple of steps shorter. That gives you fewer chances to make a mistake, but it's so fiddly. There's a decent chance that you might slip up here. The way that I would look at this question is to, if you think back to the last one, the thing that I said there, that we have an evenly spaced symmetrical set. So the mean of this set is the same as the median. Or in other words, if I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 books, well, the mean price is going to be the same as the median price. So $49.50 is the total. The mean price would be $49.50, and I'm going to divide that by 9. Okay, 49 divided by 9 is going to be 5 with 4 left over. 45 divided by 9 would be 5. So the mean price is going to be $5.50. Well, now I could very quickly find any of the prices. If I want to go up this way, I would just add $1 each time. If I want to go down the way, I'm going to take $1 away each time. $4.50, that is the 1, 2, 3, fourth cheapest book. That's the answer I'm looking for. And so my answer here is going to be B. Yeah, there's the lesson in here with the GMAT is don't necessarily leap at the first way you think of. Again, both of these will work. Both of these will be just fine. But your opportunity for making a mistake is significantly higher, and they're going to be significantly slower than if you step back and go, okay, what do I know? What's the pattern here? As we said, with a symmetrical, evenly spaced set, the mean is the same as the median. In this case, the median would be the middle book value of the book. And from there, once I know that, I can very quickly get to any value I want. And so, as we said, spot the pattern. If you can see the pattern, then these questions can become a lot simpler than they first appear. All right, those are the three sort of counting questions that we've got for you on this video, or strictly counting questions. They're going to come back a little bit later, but for now, I'm going to get into sequences for a couple of questions. So again, we're going to go back to the basics. We're going to build this up for 2 questions, and then we're going to get into a bunch of mixed topics. So I will get the first sequences question up on the screen, and I'll see you back here in a couple of minutes' time. Okay, as ever, if you need a chance to pause it, now's your opportunity. I'm going to take this question off the screen and we'll look at it together on the board. Okay, so yeah, we're into sequences. And as I said at the start of the video, we're going to have a look at what this subscript notation means. So if you're completely happy with subscript notation, you understand exactly what it means, now might be the chance to fast forward the video a little bit. We'll still be here looking at this question once we've dealt with this. So I mean by subscript notation is the difference between like this A7, A42, AN. What do I mean by that? So we've got to differentiate a little bit here between the name of the sequence, which in this case is A, and how do we tell apart each of the terms? And we do that by using these little subscripts. And so all that A7 means is it is the 7th term in the sequence. So I don't know what it is yet, but there will be a value A1, the first term in the sequence A. There will be A2, there will be A3, A4, and so on. And this number just tells you, okay, I'm looking at sequence A, and it is the 4th term, or the 7th term, or the 42nd term. Now, the way this question's set up, we are given a rule for how this sequence generates itself. The difference between n and n minus 1 here just tells you that for whatever term you're looking for, I'm going to go 1 down, 1 backwards, and I would add 3. So A4, if we start replacing the n's with A4, is equal to A4 minus 1 plus 3, or A4 is A3 plus 3, just 4 minus 1 will give you the 3. And all this tells you is the 4th term, again, don't know what it is, we could go and find it, but for now, the 4th term of this sequence is equal to the 3rd term plus 3. And that would continue the 5th term. Again, if I put 5 in for n, then n minus 1 would be 4 plus 3. The 5th term is 4, the 4th term plus 3. The 6th term will be the 5th term plus 3. And so these subscript pieces of notation are just there to tell you where in the sequence you are, if we're looking at the ones with the numbers, the 42, the 7, or they're describing a rule that tells you how to move from one term to the next. And that's all they do. They're just markers. They just tell you where in the sequence they are. And so let's go and use that to help us answer this question. So I know where A7 is. I know the value of that. I know it's 13. And I know that to get from one term to the next, I'm going to add 3. And I want to know what the 42nd term is. Now, one way of doing this is to go, right, A7 is 13, and I add 3 on, and I'll get 16, and that'll be the 8th term, and then I add 3 on, and that'll get me the 9th, and I add 3, and you could go on and on and on like that to get to the 42nd term. It's probably going to take a while. Again, in the GMAT, we're under a bit of time pressure. I can't take that long to answer a question. But I'm going to build that sequence up so that you can see how these sequences work and how we could shortcut them a bit. So I know that A7 is 13. And I know that to move from one term to the next, I'm going to add 3. So A8 is going to be 16. I'm just going to write that as 13 plus 3 over here for now. A9, well, I add 3 to move to the next term. It's going to be 19. So 13 plus 2 3s. A10 is going to be 22, or 13 plus 3 3s. A11 is 25. 13 plus 4 3s, and one more. A12 is 28, which is 13 plus 5 3s. So maybe you're spotting the pattern here, maybe not. But what we're looking for is, look at the number of moves that we've made and how many 3s we've added on. So if I could make the jump here. I've made 1, 2, 3, 4, 5. There are 5 moves, and I've added 5 3s at the bottom there. And so if you know the number of moves and you know what you do on each move, then you should be able to make the jump in one go. And we'll look at how to do that with this question in just a second. I'm just pausing here so that I can emphasize that the difference between the number of moves in a sequence question and the number of terms that we just looked at in counting questions, they're different. As I say, there are actually 6 terms here, but I've made 5 moves, and you've got to be careful to keep those two separate. In this question, the sequence, I want to know the number of moves. 7 to 12 would give me 5. And look, 12 I go from the 7th term to the 12th term, you can figure out the number of moves far more quickly by just doing 12 and taking away 7, and that'll tell you. So in this question, I want to go from from A7 to A42. Now the number of moves, I can find that by just doing 42 minus 7, the difference in the number of terms, in this case, 35. The change is plus 3. And so the total change, sorry, when I say change is plus 3, that's the change in each term. But then the total change is going to be, I'm going to make that same change each time. So 35 times 3, which is going to be 115. Sorry, 105. What am I talking about? And so my final value, the A42, is going to be the 13 that I started with plus 35 times 3, or 13 plus 105, which is going to give us 118. So our answer here is D. Now, with this process, you've got to be a little bit careful about, in this case, I was going from A7 to A42. So I was going up the sequence. Now, I was told I was adding 3 each time as I moved from AN minus 1 to AN. As I went up the sequence, I added 3. There are sequences questions where you have to go backwards in the sequence. They might give you A42 and ask you what A7 is, but they give you the rule to go up the sequence as they have done here. If you get this one, we could just reverse the algebra here. If I said AN minus 1 is equal to AN minus 3, going back down the sequence, I just take away 3 each time. So you've got to be a little bit careful about which way you're going. Am I going up the sequence? Am I going down the sequence? Do I need to follow the rule I was given? Do I need to reverse the rule I was given? And then you're looking for, what's the difference in the number of terms? How many moves do you make? Multiply the number of moves by the difference between each term, and then add that on. And that should help you get through sequences questions a lot more quickly. Now that works for sequences questions where there's an addition. There's a slightly different way when there's a multiplication, but we'll get into that a little bit later. So I will get the next question up on the screen, and we'll see you back here in a couple of minutes' time. Okay, pause the video now if you want a little more time. We'll still be here when you finish the question, but I'm going to take it away so that we can look at this one. So did you spot the pattern here? Because this is a lot better disguised than the last question. This is a sequences problem, different type of sequences problem, but it's still a sequences problem. The last one was very explicit. They gave you the sequence, they gave you the subscripts, and it was just go from this term to this term. This is a sequences problem, but it's buried amongst a load of words. So first job here is I'm going to turn this question into the sort of explicit question you had in the last problem. And so first sentence here, a certain population of guinea pigs double each month. That gives us the rule. So we could say that as we're moving from one term to the next, we times it by 2. That's our population doubles. If I know what the population is today, in 1 month's time, it's going to be doubled. Then we're told that if there are 10 guinea pigs in the population today, so we're not really explicitly told a sequence there, but I could just call this the first term. Today, we're starting today. There are 10 guinea pigs today. How many additional guinea pigs will be added to the population in the next 6 months? Now, okay, word additional there, we need to be careful with that. But what I could say to be starting with is I could answer this question if I knew how many guinea pigs there would be in 6 months' time. Now, if the population doubles every month and we're moving for 6 months ahead, that's the equivalent of saying I want to make 6 moves. And so really, I'm looking here for what's the value of the 7th term in this sequence. Now, again, small sequence in this case. The challenge here is deciphering what the question is asking you for. This is a small sequence. You could go and take 10 and then double it and then double it and then double it and then double, and just follow that process until you get to A7. Fine. Yes, in this question, it would get you there. But I want to look at a different way of doing it because I want to know what would happen if they asked for a 324 or 2,725. If you've got to move a great big number of terms in one go, you don't want to be standing here just going, yeah, okay, what do I do if I take 10 and then double it and then double it and then double it, and just have to keep following that process. So in a similar way to the way we did last time, I'm going to look at a couple of terms. We're going to build this pattern up and then sort of say, well, how does this apply into these questions? So we said we'll start with 10. And then the next term, we're going to double it, which is 10 times 2. Next term would be 40, which is 10 times 2 times 2, or 10 times 2 squared. One more of these, we'd get to 80, or 10 times 2 times 2 times 2, or 10 times 2 cubed. Okay, so again, we're looking at how many moves did I make? In a sequences question, how many jumps did I go? So A1 to A4, I had to make 3 moves. And that, you'll see, matches up with the power of 2 in this case. Now, I'm told that the sequence doubles. That would be different. If it tripled, I'd have 10 times 3 cubed. The power matches the number of moves in a sequence where you're multiplying. And so, as you can see, we're going from A1 to A7. Well, the number of moves, we could just do the 7th term minus the first term. So 7 minus 1 will give me 6. I'm going to make 6 moves. This is going to be 10 times 2 to the power of 6. I get the 6 from the number of moves. And we can jump from where we start point to where we need to be very quickly. So the 7th term, then I'll come down here, is 10 times 2 to the power of 6 is 64. So 640. Now, again, the challenge here is we're not done. It feels like we're done. We found the term that we were looking for. Feels like we're done. But again, how many additional guinea pigs will be added to the population, not how big is the population. Again, they're not trying to trap you. They haven't hidden that anywhere. It's written in plain sight. You've just got to be careful with what you're doing. So the number of additional guinea pigs that have been added, we've got 640 now. We started with 10, so we've added 630 guinea pigs to the population. So our answer here is D. So again, these sequences question, if you know how to make the big jumps, as I say, number of moves, and then that'll give you the power in this case, that should enable you to get through these questions relatively quickly. But as you can see, they can hide a sequences question fairly well on this exam. So if you can spot the pattern, you can get there a lot more quickly. Right, that's all I've got for you on the explicit sequences questions. We're going to move into the final section of this video now, which is just spot the pattern. We could have anything and everything coming your way in the next 4 questions. So I'll get the next one up on the screen and I'll see you back here in a couple of minutes' time. Okay, pause the video now if you need a little more time on this one before I take it away. So this question, or this sort of question, a lot of students find this very frustrating. That it looks easy, but it trips up a surprising number of people. And again, this is all in how carefully you read, how close you pay attention. I think the problem here is that it looks so easy that people relax and they try and go quickly, or they try and make up some time. They try and save time on a question like this, and they don't really pay attention to the implications and slip up. So let's take a look at what's going on here. That what we know is that if P is in the set, then P plus 3 is in the set. So if I know that this number is, then I know the next one will be, and I go up 3. So in this case, if 4 is in the set, I know 4 is in, right? And because if that was P, then I know that P plus 3 will be in the set, and so 7 will be in. And we could repeat this process because now I know 7 is in. That would become the P in this process, P plus 3. The next number, well, 10 will be in the set. And if 10's in the set, then 13's in the set. And if 13's in the set, then 16's in the set. And we could keep going, 19, 22, 25, 20, and so on. Well, from this, we can very quickly see, well, 7's in, 13's in, so 2 and 3 are there. But we can't say whether 1 is in or not. Because of the way this question goes, if P is in, then P plus 3 is in. It doesn't work backwards. Or it might do, but we can't tell. We're not told. All we can go on is this information. And all we're told here is that if P is in, P plus 3 is in. We're not, 4 might be the start of the sequence. We're not told. But we can't guarantee that we can work backwards. And the way this question's worded, which of the following must be in the set? Well, 1 doesn't have to be in the set. All of these numbers do, and this will go on forever. It'll go up and up and up, but it doesn't have to go down. And so because of that, we can't say 1 has to be in the set. The only ones we say must be in the set are 7 and 13, and so D is the answer here. Again, looks ridiculously simple. And if you're sort of standing there going, I don't know why this is a problem, I understand. But as I say, a surprising number of people slip up here, and I think it's in how easy the question appears, but how carefully sometimes you should read the question and don't. So, as I say, be very careful with the wording in these. Read them carefully. Take your time. Just because a question appears easy doesn't mean that it is. And with that, we'll get on to the next one. I will get this one out of the way, and I'll see you back here in a couple of minutes' time. Okay, here's your 2-second warning. If you want to pause the video, take a little more time on this one before I take it away and we can work through this together. So one of the reasons I showed the questions up at the beginning of this video, the counting one, the sequences one, was because so that we could properly define what we meant by sequences. The GMAT will give you many questions, many different types of questions with a sequence in it, but it doesn't define itself in the same strict way that a sequences question would. Those two sequences question we looked at earlier with the an equals an minus 1 plus 3, that you're going to add 3 every single time. The second one with the guinea pigs, you're going to double the sequence every single time. Whereas there are other questions that's just, we're going to define a sequence however we want. You don't apply the same rules you did in those two strict sequences question. We've kind of got to do a bit of spot the pattern, see what's going on, and then interpret where this question's going. So that, there are strict, this is the topic sequences questions, and there are just questions that mention sequences in them, and you've got to figure out what to do. And this is the latter. So in this case, we're told, we've got this infinite sequence. So it's going to go on and on and on forever in this way. And we get given the first three terms, so 2, -5, 7. And then this bit, we're told an equals an minus 3 for all n equals 4. So that would tell us, let's put the first number in there. A4 equals A4 minus 3. So that equals A1. And we're told A1 was 2. A5 is equal to A5 minus 3. Well, 5 minus 3 is 2, so it's A2. So that's -5. A6 is A6 minus 3, and that's, A3, that's 7. So this sequence doesn't go up and up and up in the same way that the an equals an minus 1 plus 3 does. That just added 3 every time. This sequence actually goes 2, -5, 7, 2, -5, 7, 2, -5, 7. And it just repeats and repeats and repeats and repeats on and on and on forever. And so when we want to know the sum of the first 68 terms of this sequence, we can make things a little more simple. I can break this down into blocks of 3. Every 3 terms, I'm going to add 2, I'm going to subtract 5, I'm going to add 7 if we were adding up the terms of this sequence. So 2 plus -5 plus 7 will give us a total of 4. So every 3 terms, the sum of the sequence goes up by 4. Well, in 68 terms, I'm going to have, there's going to be 66. That's the nearest multiple of 3, plus the 2 at the end. In other words, I'm going to have 22 blocks of 3 plus 2 terms. And we'll figure out what they are in a second. But we said the blocks of 3, they add up to 4. So I'm going to have 22 times 4. Well, now that I get to the end of a block of 3, I'd be looking at 7. The next term, the 67th term, would be a 2. The 68th term would be a -5. And so 22 times 4 is going to be 88, plus 2, subtract 5. And so that's going to be 85. And so the answer here is B. So the key with this question is not to, just because the question says sequence, not to immediately dive into, okay, the sequence is going to go up in the same way, figure out the number of moves, figure out how I move each way. That will work on a sequences question. I know this is a bit frustrating, but the GMAT will just give you a question that says, here is a sequence. I'm going to define it how I like. It's up to you to figure out whether this is a strict sequences question or whether this is just a see where this goes and figure out what's going on question. As I say, this was the latter. This is how we answered this one. Other spot the sequence questions will be different. You've just got to be alert and be paying close attention to what the question says. All right, I'll get this one out the way and we'll see you back here in a couple of minutes' time for the next one. Okay, now's the chance to pause it if you need a little more time to look at this one. I'll take it away so that we can look at the solution here. So yeah, first data sufficiency question of the video. I've got the AD over BCE set up ready to go. Now this question is another one of those, it's not a sequences question, but it talks about a sequence. So again, we're not going to have a strict sequence that goes up and up and up by a certain amount every time. We've got to figure out what's going on here. I've got quite a nasty formula. But please don't be intimidated by it. We've just got to take it, accept it, and see where it goes. I've got 3 terms involved in this formula for the first time. So an, whatever term I'm looking for, is equal to the term 2 below divided by the term 1 below. So if I was looking for a3, I would do a1 divided by a2. If I was looking for a10, I would do a8 divided by a9. I've got these terms in little blocks of 3. And that's how we're going to find our way in here. The question that we're looking for is, what's the 6th term of the sequence? All right. Piece of information number 1. Okay, product of the 7th and the 8th term. Well, I've got no products here. I don't multiply anything. It appears useless. It doesn't appear helpful. But again, we've got this little block of 3. Let's play with the terms and see where this goes. So the 7th, 8th, and I'm looking for the 6th term. So 6, 7, 8 all together. The an, that would be the biggest term, so I'll put a8 in there. An minus 2 would be the smallest term, and a7 is going to go on the bottom. Now, the product of the 7th and the 8th term is what I've been given, and I can get the product of the 7th and 8th by multiplying both sides here by a7. And that would give me a6. Well, I'm told that the product of the 7th and the 8th term is 1 over 3125. Well, I know a6. That's given me a6. So number 1 is sufficient. So I can cross out BCE over here, and let's move on to number 2. All right, this time, the 3rd term and the 5th term. So we're looking for number 6. We've got 3 and 5. At the moment, that doesn't appear particularly helpful. If I had 4 and 5, I could find 6, but I don't. But I do have 3 and 5. So could I find 4? Well, again, let's go back to the formula. 3rd, 4th, 5th term in order. So the 5th term would be the biggest one. The 3rd term the 5th term is the highest numbered term. The 3rd term would be the smallest numbered term, and the 4th term would go in the middle. an minus 2, an minus 1. They all slot in that way. Well, that means I could find a4. Rearranging this, it would be a3 over a5, or in other words, it would be 5 divided by 125, so it would be 1 over 25. Okay, well, now that I found a4, again, going back to my formula to begin with, I could have a6 is equal to a4 over a5. Again, an minus 2, an minus 1, just using that formula with the blocks of 3 again. Now, I'm not going to plug the numbers in because this is a data sufficiency question, and I don't have to actually know what a6 is. I've got a4, it's 1 over 25. I was told what a5 was, that's 125. So that should be enough there for me to figure out what a6 is. So 2 is sufficient. I can cross out A, and the answer to this one would be D. So this is another one, as we said, it's not a sequences question, but it involves a sequence. And when they give you a rule, it's sort of, they can look intimidating, but if you can sit back, accept them, and say, okay, let's see where this goes, these questions can turn out to be nowhere near as nasty as they look. All right, on that theme, I've got one more question for you. If you spot the pattern, this one might not be a huge challenge. If you don't spot the pattern, this could be quite tough. I will see you back here in a couple of minutes' time to take a look at the final question for today. Yeah, I hope that was enough time to take a look at this one. If not, now's your chance to pause it before I take the question away so that we can look at this one together and finish this video off. So again, this question, if you spot the pattern, this is going to be 3 or 4 lines. It's not going to be that long. It's not going to be that tough. If you can't spot the pattern, this is going to get very difficult, unfortunately. Now, we've got to be a little bit realistic. The people who are writing the GMAT questions, they know that you've got 31 questions, 62 minutes. You've got 2 minutes per question. You do not have a calculator. They are not expecting you to multiply together. I mean, how many? We're going to have 99 terms there. They're not expecting you to be able to multiply 99 different fractions together with whatever comes out getting more and more and more complex. It's just not feasible. There's a way around it. And when you see a question like this, there's 2 different styles. It's either the product of a great big series of numbers, so this times this times this times this, or it's the sum of a great big series of numbers, typically where they've got some sort of setup like this. Then you'll see a lot of cancelling, and that's what we're aiming for. So what I suggest you do when you see a question like this is to begin writing out the terms, get yourself a bit of a sequence, and you're aiming to spot what cancels. So in this case, the first term would be 1 plus 1 over 2, and I'll stick them in brackets so that they can just be the product of each other. The next one would be 1 plus 1 over 3, 1 plus 1 over 4, 1 plus 1 over 5, all the way up to 1 plus 1 over 98, 1 plus 1 over 99, and 1 plus 1 over 100. Now, at this stage, I can't see much of a pattern here, but it's important with stuff like this to write them out and don't jump that step. Don't skip this step, because sometimes this is the step where you see the pattern. Now, I don't have it here, so I'll take the next step. 1 plus a half, well, that's 3 over 2. 1 plus a third, 4 over 3. 1 plus a quarter, 5 over 4. 1 plus a fifth is 6 over 5. Sorry, I don't need a plus sign there. We're going to multiply all along. 1 plus 1 over 98 would be 99 over 98, would be 100 over 99, and the final term would be 101 over 100. Now, hopefully at this stage, you're beginning to see the pattern here and see what goes on. There's a lot of cancelling. I've got a 3 on the top of this fraction and a 3 on the bottom there. I can cross both of those out. 4 on the top here, 4 on the bottom there. I can cross both of those out. And I can just keep this process going. There would be a 6 here, so I can cross the 6 out. There would be a 98 on the top somewhere, so the 98s would go, the 99s would go, the 100s would go. I don't have anything at the end to cross the 101 out with. So everything would have been crossed out, except for the 2 on the bottom here and the 101 on the top over there. So this whole thing cancels down to 101 over 2, or 50.5, and so the answer for this one is C. So as I say with these questions, if you can spot that pattern, everything cancels and it turns into a 2 or 3 line process. What I would suggest is don't skip the first step. I know you can look at that 1 plus 1 over m, and if m was going to be 2, you can jump straight to 3 over 2. Fine. In this question, yeah, that's the step we wanted. In other questions, it's actually going to be the first step, the unsimplified step, which is where you see the cancelling. And if you skip that, it's going to be a lot harder to spot. So take your time, work through the steps, and build the sequence up. When you spot the pattern, great. Cancel loads of stuff and see what's left. It should be a relatively simple question from that stage. All right, so as you've seen in these final 4 questions, once we split out from the strict counting and sequences question, there's lots of questions in the GMAT that are just about pattern spotting. They might say they've got a sequence in the question, but it's not that strict sequences way of doing things that we looked at in the 4th and the 5th question today. If you can spot the pattern in these problems, as you've probably seen as we've gone through the video, once you spot the pattern, they're not that bad. It's about spotting the pattern that is the challenge. If you can, typically it's easier to do that if you slow down, read the question really carefully, understand what you're being asked to do, and then go and do it. It's when people dive in or rush in, that's when the problems arrive. All right, I hope this video has been helpful for you. We will see you back here again very soon for the next in our GMAT Ninja Quant series. Thank you very much.